Hello, athletes. Welcome to week 9. We are going to continue our lesson from last week, and we're going to continue taking a look at how you can use trigonometry to find missing side lengths in right triangles. On Thursday, we looked at cases where in our equation that variable was in the numerator. Today, we'll take a look at cases where the variable might end up in the denominator and how you use algebra to solve it. There's only one screencast this week, so make sure that you complete the practice, and then your benchmark is due by 7 p.m. on Friday. If you have any questions, feel free to send me an email. If you're completely lost, then we can set up a Google Meet and kind of walk through some of the problems together. So just make sure that if you are lost or having trouble, just send me an email. On this screen, this is an important diagram that you might want to add to your notes. Oftentimes, you'll have application word problems where they might talk about angle of elevation or angle of depression. Now, they both include the horizontal. So if you look at this man's line of sight, that is that horizontal segment that you see. The angle of elevation is the angle formed between the horizontal line and then when he looked up at that plane. So this is the angle of elevation. So again, it's measured from the horizontal upwards. Angle of depression is the angle measured from the horizontal downwards. So I would definitely include that in your notes. If you want to change this to a cat, that's totally cool too. Now, number one, this might look familiar because we did some examples last Thursday. For this, if given the angle measure, you can use a trig function to find a missing side length of a right triangle. We're going to do exactly that, and we want to make sure that we round to the nearest tenth. So this is what a problem would look like. You have a right triangle, one of the acute angles is labeled, one of the sides has a number, and one of the side lengths has an x, and then the third side is just blank. So we want to draw attention to the acute angle that we're working off of. So 51 degrees. Based off of this angle, I'm going to label the side lengths I'm going to label the hypotenuse, which is always across from the right angle. If I touch the angle, I'm touching the adjacent side. And then the opposite side is the side length across. So that's always a key strategy, is labeling those sides. Now, we've got to figure out what trig ratio we're going to use in our equation. So should we use sine, cosine, or tangent? Take a closer look at what you labeled. What side length had the x? What side length had the number? So hypotenuse and opposite. What trig ratio uses the opposite side and the hypotenuse? If you said sine, you are correct. So in our equation, we're going to have sine of 51 degrees, and then we're going to set it equal to the opposite side length over the hypotenuse. Again, if you want to put the trig function over 1 so that you treat your equation as a proportion, you absolutely can do that. Now, when I solve this equation, I'm going to use my cross product property. So I'm going to multiply across 14 times 1, set it equal to what I get when I multiply across here. So x times sine of 51 degrees. And now I want to get x by itself. The opposite of multiplying by the sine of 51 degrees would be to divide both sides of this equation by the sine of 51 degrees. So I'm going to do exactly that. On the left-hand side, anything divided by itself is 1. So that is going to give me x all by itself. And then I would go to my calculator and I would type in 14 divided by the sine of 51 degrees. If you don't have a calculator at home, then I recommend that you use the Desmos scientific calculator. And do this right now because you want to make sure that you're in the right mode on whatever calculator you're using. And you should get about 18 if you round to the nearest tenth. Let's take a look at another example. Here's the problem. Here's the acute angle labeled. So I always kind of like to circle it. And then I'm going to label the side lengths. The hypotenuse side is always across on the right angle. If I touch the angle, I'm touching the adjacent side. The only side length that's left is the opposite. And the opposite side length is always across from the angle that you are working on. So to figure out if I use sine, cosine, or tangent, what side length had a number? Well, the opposite side. What side length had a variable? That's the adjacent side length. What trig ratio uses the opposite and the adjacent? If you said tangent, then you are correct. So set up your equation using tangent of the 43-degree angle that was labeled. Tangent of 43 degrees, you will set it equal to your ratio. So you're going to set it equal to the opposite side length, which is 17, over the adjacent side length, which is x. If you want to put the trig function over 1, you can. You happen to have a proportion. So to solve it, you'll use your cross product property. You'll multiply across 17 times 1. Set it equal to what you get when you multiply across in the other direction. So x times the tangent of 43 degrees. Now, when I look at this equation, I want to get x by itself. The opposite of multiplying by the tangent of 43 degrees would be to divide by the tangent of 43 degrees. So I'm going to do exactly that. And over here, this is going to cancel to be 1. And so x is by itself. When you go to your calculator, you'll enter in 17 divided by tangent of 43. And rounded to the nearest tenth is about 18.2. Number 3. So here's an application problem. A 20-foot wire supporting a flagpole forms a 35-degree angle with the ground. So this is the wire. One strategy when you're doing word problems is people will label the side lengths with what they are. So some kids might write the word wire. They might write ground here, and they might write flagpole. So those are all tips that you can do. To the nearest foot, how high is the flagpole? So we're trying to find the height. So that's going to be this vertical side here. So I'm going to label it with an X. This is the wire, and I know it's 20 feet. And the wire and the ground, there's a 35-degree angle formed between the ground and the wire. So I'm going to label this side with 35 degrees. I'll label my hypotenuse, my adjacent side, and the opposite side. And then I've got to figure out what trig ratio should I use, sine, cosine, or tangent. So again, just like on the last two problems, what side length did I know? I knew the hypotenuse. What side length did I not know? I did not know the opposite side. So what trig ratio uses the opposite and the hypotenuse? If you said sine, you are correct. So let's set up our equation. Sine of 35 degrees, set it equal to the opposite over the hypotenuse. And so here's your equation. Use your cross product property. So x times 1, x is all by itself. That's nice. 20 times sine of 35. And then you'd go to your calculator. Said to the nearest foot. So that means the nearest whole number. So the flagpole is about 11 feet tall. Number 4, a man flies a kite with a 100-foot string. The angle of elevation, so there's one of those vocab words that we started in the very first slide. The angle of elevation is that angle formed between the horizontal and upwards. So this right here is my angle of elevation, and it measures 52 degrees. How high off the ground is the height? So I'm trying to find the height of the kite. So here's the kite flying right here. Here's the string. I label my sides, so the hypotenuse, the adjacent, the opposite side. There's my adjacent side, because if I touch the angle, I'm touching the adjacent side. I've got to figure out what trig ratio to use. So I look closer, and I know the hypotenuse, and I want to find the opposite. So what trig ratio uses the opposite side and the hypotenuse? If you said sine, you are correct. So let's set up our equation. Sine of the angle, so sine of 52 degrees, set it equal to the opposite side over the hypotenuse. And then solve your proportion. X times 1 is x, 100 times sine of 52. Oops, I don't know why that says tangent. Let's make sure it's right. So 100 sine of 52, it should be about 78.8. And that is, yeah, that's the last one. So again, what you want to make sure that you're comfortable with. So now we've covered all the different cases of how to find missing side links using trig. And there's really two cases with after you set up your equation, either x is in the numerator or x is in the denominator. So we've covered both cases. I'm going to link a fun little music video that covers all the cases, which it might seem silly, but it's actually a really good video because it summarizes all of trigonometry. So I'll link that video. This is the only screencast for the week. So really this week, you want to make sure that you're completing the practice. And if you have any questions, feel free to send me an email. If you're completely lost, like I said before, we can set up a Google Meet if you're completely lost. And I hope you have a wonderful week, guys. Bye.